Hello and welcome back to my channel Skill Knowledge. Today we are going to deal with the accessory structures of eyes. We keep making such educational videos. If you are new to the channel, do subscribe and hit the bell button to see more such videos. So without delay, let's get started. Vision. The act of seeing is extremely important to the human survival. More than half the sensory receptors in the human body are located in the eyes, and a large part of the cerebral cortex is devoted to processing the visual information. So, vision, the act of seeing, is due to the electromagnetic radiation. Electromagnetic radiation is the energy in the form of waves that radiates from the sun. There are many types of electromagnetic radiations, including the gamma rays, X rays, UV rays, visible light, infrared radiation, microwaves, and the radio waves. This range of electromagnetic radiation is known as the electromagnetic spectrum. The distance between two consecutive peaks of an electromagnetic wave is called the wavelength. Wavelengths range from short to long. For example, gamma rays have wavelengths smaller than a nanometer, and most radio waves have wavelength greater than a meter. The eyes are responsible for the detection of visible light, the part of the electromagnetic spectrum with wavelengths ranging from about 400 to 700 nanometer. The color of visible light depends on its wavelength. For example, the light that has a wavelength of 400 nanometer is violet, and the light that has a wavelength of 700 nanometer is red. For example, a green apple appears green because it reflects mostly green light and absorbs most other wavelengths of visible light. As we have seen how vision and electromagnetic radiation is related, let us see what are the accessory structures of the eye. Accessory structures mean the extra structures that contributes in the functioning of overall eye. The accessory structures of the eyes includes the eyelids, the eyelashes, the eyebrows, the lacrimal apparatus, and the extrinsic eye muscles. First one is the eyelids. The upper and the lower eyelids, or the palpebra, shades the eyes during the sleeps and protects the eyes from excessive light and foreign objects, and spread the lubricating secretions over the eyeballs. The space between the upper and the lower eyelid that expose the eyeball is the palpebral fissure. Its angles are known as the lateral commissure, which is narrower and closer to the temporal bone, and the medial commissure, which is broader and nearer to the nasal bone. In the medial commissure, there is a small reddish elevation, the lacrimal caruncle, which contains the sebaceous oil glands and the sudoriferous sweat glands. The whitish material that sometimes collects in the medial commissure comes from these glands. From superficial to deep, each eyelid consists of an epidermis, a dermis, a subcutaneous tissue, fibers of the orbicularis oculi muscles, a tarsal plate, tarsal gland, and the conjunctiva. The tarsal plate is a thick fold of connective tissue that gives form and support to the eyelids. Embedded in each tarsal plate is a row of elongated modified sebaceous gland known as the tarsal or the meibomian gland that secretes a fluid that helps keeps the eyelid from adhering to each other. Infection of these tarsal gland produces a tumor or a cyst on the eyelid called the chalazion. The chalazion is the small bump. The conjunctiva is a thin protective mucous membrane which is composed of the non-keratinized stratified squamous epithelium with numerous globulate cells that is supported by the areolar connective tissue. The palpebral conjunctiva. The palpebral conjunctiva lines the inner aspect of the eyelids, and the bulbar conjunctiva passes from the eyelids on the surface of the eyeball, where it covers the sclera, that is the white part of the eyes but not the cornea, which is the transparent region that forms the outer anterior surface of the eyeball. Over the sclera, the conjunctiva is vascular. Dilatation and congestion of the blood vessels of the bulbar conjunctiva due to any local irritation or infection are the cause of bloodshot eyes. The next accessory structures of eye are the eyelashes and the eyebrows. The eyelashes, which project from the border of each eyelid, and the eyebrows, which are transversely above the upper eyelids, helps protect the eyeballs from the foreign objects, perspiration, and direct rays of the sun. The sebaceous gland at the base of the hair follicles of the eyelashes, called the sebaceous ciliary glands, release a lubricating fluid into the follicles. Infection of these glands, usually by bacteria, causes a painful pus-filled swelling that is called the stye. The next accessory structure is the lacrimal apparatus. The lacrimal apparatus is a group of structures that produce and drains the lacrimal fluid or the tears. The lacrimal glands, each about the size and shape of an almond, secretes the lacrimal fluid which drains into 6 to 12 excretory lacrimal ducts that empties the tears on the surface of the conjunctiva of the upper lid. From here, the tears pass medially over the anterior surface of the eyeball to enter to two small openings called the lacrimal puncta. Tears then pass into the ducts, the lacrimal canal, which lead into the lacrimal sac and then into the nasolacrimal duct. This duct carries the lacrimal fluid into the nasal cavity, just inferior to the inferior nasal concha. An infection of the lacrimal sac is called the dacryocystitis. Next, we will see is the extrinsic eye muscles. The eyes sit in the bony depressions of the skull called the orbit. The orbit helps protect the eyes, stabilize them in three-dimensional space, and anchor them to the muscles that produce their essential movements. The extrinsic eye muscles extend from the walls of the bony orbit to the sclera, that is wide part of the eye, and are surrounded in the orbit by a significant quantity of periorbital fat. Six extrinsic eye muscles move each eye: the superior rectus, the inferior rectus, the lateral rectus, the medial rectus, the superior oblique, and the inferior oblique. They are supplied by the cranial nerves, third, fourth, or sixth. In general, the motor unit in these muscles are small. Such small motor units permit smooth, precise, and rapid movement of the eyes. The extrinsic eye muscles move the eyeballs laterally, medially, superiorly, and inferiorly. For example, looking to the right requires simultaneous contraction of the right lateral rectus and left medial rectus muscles of the eyeball, and relaxation of the left lateral rectus and right medial rectus of the eyeball.